First problem. 3x minus 1 is greater than or equal to 5. How do I answer that particular problem? What's my working? Add 1 to both sides. So now this is 3x is greater than or equal to, sorry, I should be probably writing it over here, greater than or equal to 6, because 5 plus the 1 is 6. Now what do I do? Divide both sides by 3. Exactly the same as what I had been doing. And I keep the same sign. All I do. So instead of writing an equal sign, you're writing that same sign. Next one. X over 3 is greater than or equal to 4. What do I do there? Times both sides by 3, so times the whole side by 3 if you like. X is greater than or equal to 12. Here's my answer. Next one. Negative 2x is less than 4.
Minus 2.
What do you reckon, Dominic? What would I do there? Should we pause the video? Hold on. What am I going to do there, gentlemen? Divide by negative 2. Okay. Divide by negative 2. Divide by negative 2. Doing that, that's my answer. Okay. Doing what I've told you, exactly the same. Keep the signs exactly the same. Divide by negative 2. 4 divided by negative 2 is negative 2. So x is less than negative 2. Are we happy with that?
Yeah.
Okay. That's wrong. Okay. The reason why it's wrong. What? X times negative 2 has to be less than 4. Okay. So what could x be? Could x be 0? Negative 2 times 0. What's that? That's less than 4, eh? So x could be 0. What? But we're saying here x has to be less than negative 2. 0 is greater than negative 2, isn't it? So what it's actually saying to me is there's my answer. Okay? And that's correct. And so this is the little trick with inequalities, which is not something that I like to teach because it's a trick. If you are dividing by the negative 2, what you have to do is you have to flip your inequality. Okay? That's the trick. But what have I been trying to get you to do with the linear equations? Deal with not whole numbers but positive numbers, eh? So rather than divide by negative 2, what I want you to do is to add 2x to both sides. And then subtract 4 from both sides. It's a roundabout way of doing it, but what you're doing, in other words, is moving the 4 to the left and the negative 2x to the right, so you're getting a positive 2x. Because now when I divide by my 2, that's what I'm getting. X is greater than negative 2, which is what I want in the first place, eh? So can you see that? So do you remember me saying, make sure you're trying to deal with positive x's? That's the reason why. You don't have to remember the trick then. Okay? You have to do a little bit of extra maths to add 2x and subtract 4, but really by the end of the day, that should be relatively easy for us when the time comes. So, D. We'll carry on. D, what am I going to do there? Step 1. Add 1 both sides. 4/3 of x less than or equal to 6. Now what am I going to do? Times it all by 3 because I don't like that fraction. Okay. Times it all by 3. 4x less than or equal to 18. Now what? Divide by 4. Divide by 4. x is less than or equal to 18 over 4. There's my answer. Can I simplify it? Can I simplify 18 over 4? Yep. Do I have to? No, it could be 9 halves. You don't have to, okay? We're trying to assess your ability to solve algebraic problems, not simplify a fraction, which is a number skill. Okay, so it's algebraic problems I'm trying to get you to solve here. And the last one, which side are we going to move our x's to? The right, because you don't want your negative x's. So, subtract 3x from both sides, leaves me with 2x. Subtract 1 from both sides, leaves me with negative 5. I keep that same symbol. Now I divide both sides by 2, and I'm left with negative 5 over 2 is x. There's my answer. Okay? Does that make sense? Does that seem a little bit easier than potentially what that row on that sheet was? Yeah? Okay.